To do any architectural design, it is very much important to understand the site and its environmental factors. In this video, the proposed site for 1 million settlement on Mars will be explained briefly with its natural, environmental and geological condition. Mars is the fourth planet from the Sun. The average distance of Mars from Earth is about 78 million km. Its next closest approach to Earth is on October 6, 2020. At this point, Mars will be at a distance of 62.12 million kilometers. A day on Mars is 40 minutes more than that of Earth. And it has a slower orbital speed. A Martian year is 687 Earth days long. Like Earth, Mars has seasons. It has a 25-degree tilt similar to Earth. Since the Martian year is twice as long, its seasons are longer too. In this diagram, the northern hemisphere seasons are shown. Because Mars has an elliptical orbit, some seasons are longer than others. The diameter of Mars is about 53% that of Earth. Mars is less than 1/6 the volume of Earth. It has 1/10 of the mass of Earth. On Mars, the gravity is 3.71 meter per second square, which is about 38% of Earth's gravity. Earth and Mars are similar when it comes to their basic makeups, given that they are both terrestrial planets. Both planets have a silicate mantle surrounding their iron-nickel cores, and a surface crust of solid material. Atmospheric pressure and temperatures are another way in which Earth and Mars are quite different. Earth has a dense atmosphere, whereas Mars is very thin by comparison, with pressure ranging from 0.4 to 0.87 kPa, which is equivalent to about 1% of Earth's at sea level. You can say this is almost a vacuum. The atmosphere of Mars is primarily composed of 95.32% carbon dioxide, 2.6% molecular nitrogen, and 1.9% argon. It also contains trace levels of water vapor, oxygen, carbon monoxide, hydrogen, and other noble gases. There is quite a difference between the average surface temperature of Earth and Mars. On Earth, it is approximately 14 degrees Celsius. The surface temperature of Mars is much colder, averaging at a negative 46 degrees Celsius, because of its thin atmosphere, and its greater distance from the Sun. However, because of its tilted axis and orbital eccentricity, Mars also experiences considerable variations in temperature. These can be seen from a low temperature of negative 143 degrees Celsius during the winter, at the poles, and a high of 35 degrees Celsius during summer, on midday at the equator. Mars' greater distance from the Sun means that the maximum intensity or brightness of sunlight is much less, about 44% than that on Earth. From the Sun, Mars receives a power of 589 watt per square meter compared to Earth's 1367 watt per square meter. No one has ever seen it, but it probably gives the impression of dawn or dusk during the daytime. Mars has no protective magnetosphere, as Earth does. As a result, the Mars atmosphere was slowly stripped away by the solar wind. Because of the loss of its magnetic field, and its atmosphere, the surface of Mars is exposed to much higher levels of radiation than Earth. We're all exposed to low levels of radiation on the surface of Earth, but most of it is deflected by our thick atmosphere and magnetic field. Even the spacecraft designed to shield fragile organic beings can't stop all the dangerous cosmic rays. A day in space hits astronauts with as much radiation as a year on Earth. The ESA estimates that astronauts on a mission to Mars would get radiation doses up to 700 times higher than on Earth. Martian surface is covered with dust, called regolith. It is fine like talcum powder. The soil of Mars also holds nutrients, such as sodium, potassium, chloride, and magnesium. Beneath the layer of dust, the Martian crust consists mostly of volcanic basalt rock. The crust is between 6 to 30 miles, or 10 to 60 kilometers thick, according to NASA. Mars' crust is thought to be one piece, or one continent. You may say, unlike Earth, the red planet has no tectonic, which means there is no quake on Mars. Micrometeor is a small particle of rock in space, usually weighing less than a gram. A micrometeorite impact is such a particle that survives entry through the atmosphere and reaches the surface of a planet. These rocks from the sky also fall on Mars, and vehicles such as Opportunity or Curiosity encounter them from time to time during their exploration of the red planet. Micrometeor strike occurs all the time, we don't realize it, because of the protective layer of Earth's atmosphere. When an asteroid crashes into our Earth, it first strikes dense layers of the atmosphere, at incredible speed. Air friction causes the projectile to heat up extremely, at which point most are completely vaporized before they reach the ground. The case is not same for Mars. Because of its thin atmosphere, the space rocks reach to the ground. A micrometeoroid strike on ISS, creating a hole about 2 mm wide. A test was done to understand how much damage can be done by a micrometeor impact. This image shows a test impact on a thick steel block. Many Martian landscapes contain features that are familiar to ones we find on Earth, like river valleys, cliffs, glaciers, mountains, and volcanoes. Most common feature of Martian landscape are the craters. Impact craters form in a range of sizes from microscopic to giant basins thousands of miles across. There are several types of crater, like simple crater, complex crater, peak ring crater, multiple ring impact basin, unusual crater, pit crater, etc. From this study we can see that conditions on Mars are not suitable for living, but there are some favorable conditions to build structure on Mars. These are the following design considerations that should be accounted to do any architectural design on Mars. Let's discuss what are the downsides to construct any building on Mars. The first difficulty is the atmosphere. The facility has to be pressurized and oxygen supply has to be maintained. Though thin atmosphere is also an advantage that we will discuss later. Then comes the temperature issue. For the extremely cold temperature, proper insulation and the thermal system is very much essential. For low brightness and less solar energy, the design has to be done in the most efficient and sustainable way possible. Other very important issues are radiation and micrometeor impact. The design should be approached in such a way that the inhabitants that will be living there are protected. Today, it costs about $1,000 to put a kilogram of payload in low Earth orbit. Sending a payload to Mars will cost even more. Most importantly, the design of the structure has to lighter, since sending materials from Earth to space is expensive. Now, let's discuss possible advantages that could improve or strengthen the design of the structure. The low gravity of Mars is great for the construction work. Because of low gravity, the workload will be reduced, and larger, taller structures can be constructed compared to Earth. Other useful features of Mars are its craters. When doing any construction work, the digging site is a necessary job. To have craters is an advantage that no or less digging will be required. As Mars have thick hard basalt crust, it can support larger and taller buildings in comparison with Earth. Since Mars have a very thin atmosphere, the wind load will be very little or negligible on a building. So the bottom line is making a living condition will be tough, but constructing buildings will be much easier, provided that the necessary infrastructure and technologies are available on Mars.